Hi everyone, here's a video about how to solve systems of equations by graphing. So a system of equations is two equations. You'll often see a little bar connecting those two things, the two equations that you need to graph. The first one's a little easier example because they're both in slope-intercept form. They're both in mx plus b format. So if we identify the slope and y-intercept here the slope is a 1, so we're going to go 1 over 1, rise 1 and run 1. And the y-intercept is 1. So I'll graph this first one in black ink. We'll start at the y-intercept of 1. And then we're going to go up 1 and over 1 to our new point. And we'll continue to do that in that same pattern. Up 1, over 1, up 1 and over 1. And we can kind of reverse it and go the other way, but we have enough to make our line. So go ahead and make our line here. And let's see if I might need to fix it here, but that looks like pretty good. We'll straighten it out a little bit. And we'll have our line pretty good for that one there. Pretty good. It's not letting me do it exactly. But the next equation we have our already in slope-intercept form here. The slope is negative 1 over 1. So we're going to go down 1 and then right 1. And then the b value is negative 3. So that's where we're going to start here. Down 1, or down to negative 3, and we'll start there. And then from here we're going to go down 1 and right 1. So we're going down 1, right 1 to our new point. And we'll keep doing that until we kind of run out of room here. And I'd like to go back the other way to make sure we can actually find exactly that point of intersection. So we're going to go reverse the directions, go up and left. Oops. Sorry, I didn't do that right there. Up and left, 1 and 1, and we're going to go up and left again. And here's that point of intersection. Notice my black line was a little bit off, so if I could, I might fix that now. Here we go. That's close. And then we'll go ahead and graph our blue line here, the second line. When we do that, we get our system of equations, and the point of intersection is the answer to this whole system. That point of intersection is this point right here, which is negative 2 comma negative 1. And that's the solution to the system. And both of those points actually would be solutions. If we check the first equation, plugging in negative 1 for y, negative 2 for x, we do get negative 1 equals negative 1. And if we were to check it for the second equation, negative x minus 3, we plug in negative 1 for y, negative of negative 2 minus 3, sorry it's getting a little sloppy here, 2 minus 3 does give us that negative 1. So it does, it is a solution for both systems of equations, or both equations. Our second equation is just a little bit different here. What we have is we have to solve the first one for y now. The second one's good, but the first one here we just have to add x to both sides. So this equation is going to be y equals x plus 1, and then this equation is 2x plus 0. So I'll graph the first one in blue, x plus 1. We start at 1 on the y-intercept, and our slope is 1, so we're going up 1 over 1 a couple times here. So we get our line. Fix that one a little bit. Let's move this bar down. The more accurate you are with all your lines, the clearer your equations, your solutions will be. And then I'll do the second one in red here. Second equation here, 2x plus 0. Here the slope is, oops, I changed my line. Sorry, I'll change that back to blue. The second equation is 2x plus 0, so we're going at 0. And here we're actually going up 2 over 1. The slope is 2 over 1. So the first point there, we actually see our intersection point there, which is nice. So when we graph this line here in red, you'll see that the red line and the blue line are going to intersect at the point 1 comma 2. So our intersection point for this system, our solution is the point 1 comma 2. Okay. And we can plug them in and verify that they work for each equation. We have y minus x equals 1 and y equals 2x. I plugged them into the original equations. You could actually plug it into this one as well too. Y is 2, x is 1, and we see that 1 does equal 1. And then when we plug in y again here, 2 equals 2 times our 1, and we see that that's true also. So algebraically we verified that those work out. Thanks guys, see ya.